Okay, this is Spidey Man talking. Spidey Man says, Baba, Spidey Man says, you better make sure this is working. Okay, Spidey Man says, Baba, when your grandsons ask you a question, you will answer. You will answer. And if you don't answer, you will answer to me. Okay, so I'm so glad when you guys ask questions. I really like answering them, and I hope that sometimes some of the answers are interesting enough so you have more questions, and someday you might actually like this stuff and learn on your own more, which is great. But I'm great. I'm a great teacher. I mean, everybody knows that. And when I get you in my little hands, it won't stop. Then at some point you'll teach me. And sometimes your questions are pretty darn good, so that I actually have to either think about them and how am I going to answer them, or I don't know the answer, and then I gotta, what do I gotta do? The old days I would go to the library and get a book, or I'd make something up. I just lie about it, which is always a good thing to do. Or I'd sing a little song, which would make it seem simple, like on my favorite show, The Magic School Bus. Sing a little song and everything's going to be okay. But sometimes I actually have to dig down. And now because we have internet, which is something you've had all your lives, but I didn't, instead of going to the library and reading up on something or finding a book, I can just look at the internet and then kind of translate it for the age group between 8 and 12, or depending on who I'm talking to. And of course, some days you guys are gonna ask me questions I just don't know the answer, and I'm not smart enough to figure out the answer from books. But so far, that's not happening very much. Lucky for me. Okay, this question was something. It started out something like this from Tail, because we were talking about Bluetooth and about wires and how electricity can go through wires and things like that. So he said, our nerves also like wires, transmitting electricity through the body. And I could say yes and then go away. And that's probably what I should have done. But no, that's not me. I don't do that. I can't just say yes and go away, because every time you ask a question, not every question, but a lot of questions, you can answer it at one level and then people can go away. You can answer it at a deeper level and people still go away. They might go to sleep. Or they might start thinking, oh, well, if that's true, what about this? And what about this? And the answers get deeper and deeper. It takes a long time to get to the bottom. At the end, nobody gets completely to the bottom of anything, but you get good enough. Okay, so let's talk about wires and electricity and how electricity is conducted, normally speaking, to ordinary wires. So the first thing I got to do, and I know you know all this already, but I'm going to start taking that information and turning it in a certain direction that you might not know as much about. So we all have heard the word atom, and everybody, including everyone who watches the Magic School Bus, knows that atoms are made of a bunch of little things called protons in the middle, and they have a plus charge. That means the electrical charge. It's a basic thing that a lot of things in the universe just have. It's part of their very being. They have a plus charge, whatever that means. Surrounding the protons are electrons. So let's for now just say that they're running around like in orbits around the protons. It's a little more complicated than that, but that's good for now. These electrons are very small. They're smaller than the protons, but they have the same charge but minus. So the rules of the charges are, and again, this is what they call an intrinsic part of nature. It's something we're not going to go into the why too much. I'm not even sure how far I could go into why. At some point, it's just that way. The way these things work is a minus charged particle, like an electron. If you have another minus electron, it'll push them. They'll try to push each other apart. If you have a plus proton and a plus proton, they will push each other apart. But if you have an electron and a proton, they'll try to pull each other together. And let's just say that's the way it is. So you've got the proton, they're all gathered in the nucleus, and then the electrons swimming around them. That's for an ordinary atom. Ordinary atom of garden variety. Garden variety is a highly technical term. It means what you find out in the yard, weeds, all that other stuff, just standard stuff you find. Garden variety ordinary atom. It's got the same number of electrons as it has protons, so altogether the number of pluses and the number of minuses are equal. Everybody's happy. It's floating around out there. That's an ordinary isolated atom. But Baba, they told us there were neutrons. That's true. There's other little blobs in here called neutrons. They add to the weight of the nucleus, but they don't change the charge. They're neutrons, they're neutral, they're not positive or negative. So for what we're doing, they're just hanging around. Being cool. They have to be there. Part of the reason is so that these protons don't blow each other apart because they repel each other. That's part of the reason. And then there's, it's just that way, and Baba doesn't know enough to explain any more than that. But Baba does know more, but not enough. Okay, so you've got the electrons circling around the protons. That's called an ordinary garden variety atom. And because the number of electrons and the number of protons for the whole atom are equal, we say that atom has a neutral charge. No plus, no minus, because they add up to zero. Just as many pluses and minuses. Zero. So that's a neutral atom. Now we have to find our giant Chinese erasing block. See it? Okay, yes, it still has a magnet. The magnet's still there. And it still works. Oh, this is a wonderful thing. This is so much better than a blackboard with chalk. The only problem is it doesn't smell good. It doesn't smell like chalk. But this smells good. No, that doesn't smell either. Okay, so we have these things called neutral atoms. That's nice. They're hanging around. When they're neutral like that, often they don't even they could just be sitting there out there by themselves. Sometimes the atoms join. You can have an oxygen atom, one oxygen atom, and another oxygen atom, and they join. They link together. O2, two oxygens. They link together for a reason. That's something else that you really have to understand in order to understand about how metals conduct or other things conduct. That's because in the orbits around the nucleus, there's a number of atoms. Sometimes in the real world, atoms feel better. They have a lower energy if they have, let's say, 8 electrons in the outside. But if there's only, let's say, 6 pluses and there's 6 minuses, something like that. I'm not talking about oxygen, but just in general. If there's 6 pluses and 6 minuses, whoops, those are supposed to be minuses. The atom is neutral, but it would feel better, and we could talk about why. It would feel better if it had 8 here and not 6. That's the way things are. So what happens is another atom comes along, which also has 6, and they kind of like share 2 spots, and they fulfill each other's destiny. This guy wants 8. I'm sorry, I said it wrong. This guy's got 8, and we'll leave it like that. This guy's got 6. This guy got 6. They come together and they share 2 of them, and then they're what's called a lower energy state. So they hang together, so that they both feel like they have 8. So even though everything was neutral, when you complete these it's called the outer ring. When you complete them, so that they both feel that they have 8 because they're sharing some of them, they're at a lower energy state, so they stick together. And that's why you can get these things called molecules, where one of the ways you can get molecules where two atoms like hang around together, not because they're attracted because of unequal charge. Charges are still all zero, but when they're linked together, the completion of 8 could be a different number, but usually it's 8. The completion of 8 makes the whole system have a lower energy level than when they're apart. So the atoms want to come together, so they're at a lower energy. It's always nice to be low energy because you can be lazy and sit in the chair. It's a lot easier walking around. It's the way those atoms feel. I'll feel better if I'm stuck to another atom. And even though the charges are all balanced, they still feel better. And how they feel better is because of a world that we're not going to talk about right now. Quantum mechanics, you've heard about it. That's for another day, another year. And I hate to say it. I hope I can be around to talk to you guys about it when you're ready to talk about such things. Hopefully it will be 3 or 4 years and everything will be okay. All right, but anyway, that's how you sometimes atoms come together, like O2, oxygen is a pair. Nitrogen always forms a pair, normally speaking. Nitrogen that we have in the air, it's called N2, because the two nitrogens are stuck together. The oxygen, O2. We also have some other combinations like carbon, which is another element, O2. Carbon, one carbon atom, and 2 oxygen atoms, they just like to hang out. It's nothing to do with their charges, but we're going to get back to the charges because this is all important. It's because the number of charges in the outer rings feel better when there's 8. Now, it depends on the ring, but I'm talking about most of the guys you're going to be talking about want 8 in the outer ring. If they don't have it, they'll get together with another kind of atom or another atom where they can share so that they both think that they have 8. Why am I talking so much about this? Because the next topic is something called an ion. An ion really does have a charge. An ion is where you have, start again with an atom with 6 protons and 6 electrons. That's neutral. If I look around the outside, there's no charge. There's as many pluses as there are minuses. Let's say I take one of the electrons away. I just take it away. Take it away with my hand. There's other ways to take it away. Now we've got 6 protons and we have 5 electrons. 1, 2, 3, 4, 5. So now there's more protons than there are electrons. So is that going to be a positively charged atom or a negatively charged atom? You figured it out already. This atom is positively charged, and it's called an ion. When it's got a charge on it, it's called an ion. You can take an electron away. The thing will still exist. It's not that happy, but it can exist, and it can float around. You can rip an electron off of it, or a whole lot of them, and those are called charged ions then. They're still atoms, but they're missing an electron because somebody took them away. Someone stole it away, didn't give it back. If it happens to meet an electron, the electron will come back on and it'll hang in. Because right now, this is positively charged, so if there's something that's negatively charged out here, they'll attract. So if I happen to have another ion, just like this, but with an extra forced electron onto it, which would mean 7 electrons, that guy will be a negative ion. So these are called ions. These ions, they can be one atom, can be an ion, or you can have a group of atoms, a molecule with different kinds of elements in it, and take away or add an electron, and those are ionic molecules. Ionic means that they're charged. So another example would be